Good afternoon again. My name is Tom Sawinski, and I work for the Department of Energy's Office of Advanced Reactor Technologies. I'm here today to present to you an exciting opportunity in the Nuclear Energy University program's mission supporting area, which supports the transformative research and development of advanced reactor concepts. To begin, I'd like to provide a brief overview of the objectives of the Office of Nuclear Energy. Then I will go into how the Office of Nuclear Energy is broken down, and then we will focus more on the Office of Advanced Reactor Technologies and some of the work taking place in that particular office. The Office of Nuclear Energy looks at several key objectives. We look to develop technologies and other solutions to improve the reliability, sustain the safety, and extend the life of our current reactor fleet. We also focus on developing improvements to the affordability of new reactors to enable nuclear energy to meet the administration's energy security and climate goals. We also look to develop sustainable new fuel cycles. We also look to develop capabilities that will reduce the risks of nuclear proliferation. In terms of our mission, we look to keep the fleet operating safely while developing new reactor technologies for deployment. This particular area is focusing more on the development of new nuclear technologies. So we look to promote technologies that have the greatest promise to enable new nuclear power. We look to conduct R&D to continue to maintain safe operation of the existing fleet. We look to honor our past commitments to other agencies. We also look to develop unique capabilities and facilities to support future research and development and policy decisions. And for this particular category, we look to explore new high-risk and high-reward technologies. Below, it shows that the Office of Nuclear Energy and the Office of Nuclear Reactor Technologies divide into three areas: light water reactor technologies, advanced reactor technologies, and space and defense power systems. This particular call will be focusing on the program area in advanced reactor technologies. This reiterates the breakdown, and I'd like to draw your attention to the advanced reactor technologies box on the screen. The Office of Advanced Reactor Technologies focuses on 5 key areas for advanced reactor research and development. These areas are fast reactor technologies, high temperature reactor technologies, advanced reactor generic technologies, advanced reactor licensing framework, and advanced reactor system studies. Within these focus areas, each has their own key objectives. For fast reactor research, we're looking for actinide management and electricity production while focusing primarily on sodium coolants. For high temperature reactors, we look both for electricity production and also to utilize the high process heat for other applications outside of electricity production, and our current focus is on gas and liquid salt cooled systems. In terms of advanced reactor generic technologies, we look at areas that will support all types of advanced reactor types. So this includes advanced materials, energy conversion, decay heat removal systems, and modeling methods. In terms of advanced reactor regulatory framework, we are continuing to develop licensing requirements to promote the development of advanced reactors. In terms of system studies, we are currently performing analyses of capital, operations, and fuel costs for advanced reactor types. So for this particular call, and for the Office of Advanced Reactor Technologies, we look to answer several key questions. How can we improve the affordability of nuclear power? How can we improve the inherent safety of advanced new reactors? How do we improve the proliferation resistance of these reactors? How can we address waste issues through advanced fuel cycle options? How can we expand into non-traditional energy markets? And how can we overall increase the performance and efficiency through new materials and advanced systems? That is what this call is seeking, to look how to either develop new radical reactor types or to enhance current designs in the Gen 4 area. Right now, I'm just going to go over some of the current research taking place in the Office of Advanced Reactor Technologies. In terms of fast reactor technologies, we focus on developing the technology and maturing it. We've already performed assessments that will guide our innovative research and development, and in terms of experimental work, we are currently finishing the first phase of the Materials Engineering Test Laboratory at Argonne National Labs, which will be utilized to test sodium components in a realistic sodium environment. In terms of advanced materials, we are currently on the intermediate term testing of 2 candidate alloys for their future qualification and use in sodium fast reactors. In terms of advanced energy conversion, we are focusing on potentially utilizing supercritical carbon dioxide cycles and looking at their interactions with sodium at a special loop that is constructed at Argonne. In terms of safety and in terms of risk reduction, we're looking at various licensing aspects, and we're also looking at capital cost risk reduction. And finally, in terms of in-service inspection for sodium fast reactors, we're looking at innovative ultrasonic viewing technologies. Moving to high temperature reactors, we'll first focus on high temperature gas reactor work, and then we'll follow up with high temperature fluoride salt cooled reactors. In terms of high temperature gas reactors, we currently have a strong program ongoing to establish the licensing basis for coated fuel particle fuel, also known as TRISO fuel. We've done several tests so far in terms of accident scenarios at several high temperatures with no failures, and we have established a successful commercial fabrication process. In terms of passive decay heat removal, the natural convection shutdown heat loop at Argonne has been evaluating ex-vessel passive decay heat for high temperature reactor systems, while at Oregon State University, they're currently finishing up construction of the high temperature test facility to also validate decay heat removal capabilities. And in terms of materials, we are currently pursuing work for qualification for high temperature materials and on graphite. For fluoride high temperature reactors, we primarily support them through a NEOP-funded integrated research project. In 2014, we recently awarded 2 more projects to look at specific design challenges associated with fluoride high temperature reactors. In terms of international collaboration, we currently collaborate with China on their FHR test reactor activities, and we have been supporting the Czech Republic's program with salts we have provided them in 2013. Now that we have a brief overview of some of the work performed on advanced reactors, I'd like to show you the exact scope and what we're looking for this mission supporting item. Before I read it, I'd just like to reiterate this is a chance to provide revolutionary improvements to reactor systems or to provide radically different and new innovative reactor concepts. So such advanced reactor concepts, we could include incorporating advanced systems and components into existing concepts with a specific focus on Generation 4 systems. We can look for inclusion of innovative design alternatives into current advanced concepts, such as new fuel types, nano-engineered coolants. We can also look at employing radically different technology options, such as advanced coolants, new fuel or operational regimes. Or also, we are looking at reactors with unique capabilities to address operational missions outside of just baseload electricity production. This can include areas such as desalination or small mobile reactors. Since this is a more conceptual work scope, it's very important to know that the scope of your project should include an assessment of your concept's technical viability. It should also include a detailed technological gap analysis, and finally, a comprehensive technological development roadmap that identifies the research needs for key feasibility issues. Right now, I'd just like to conclude with a slide on some of the previous year's awards, just to give you an idea of the breadth of items that can fall under this category. In FY14, we looked at the development of a small integral reactor, which integrated the power production, power conversion, and electricity generation into one single small unit. Fiscal year 13, we supported work for tritium mitigation and control systems for FHRs. And in fiscal year 12, we also looked at stationary liquid fuel fast reactor concepts, which can be used for transuranic waste burning. As you can see, we have a large spectrum of items that have been supported underneath this in the past. So in summary, the Office of Advanced Reactor Technologies pursues several advanced reactors, such as high temperature reactors that are both gas-cooled, and also sodium-cooled reactors. Liquid salt reactors are also funded via the IRP process. Different technologies can also be looked at the technical review panel, which looked at several options in 2012 and 2014. So to reiterate, the MS-RC1 scope looks at major innovations for advanced reactor concepts or radically different new technological options. And as the slide stresses, this is your opportunity to think outside the box to potentially influence the future of advanced reactor research and development in the United States. Now I'll open up the floor to any questions you may have.
On slide 7, can we know what the 2 alloys in progress are for immediate term testing?
Right. So the 2 alloys currently in progress would be grade 92 steel and alloy NF709.
Does high temperature reactor mean pebble bed or prismatic reactor?
Both reactor concepts can be included in this particular call. So yes, it refers to both prismatic block high temperature reactors or pebble bed high temperature reactors.
What were the materials again?
Materials were grade 92 steel and alloy 709 for the fast reactor qualification.
Is there interest in systems and economic analyses performed on small modular reactors for cost reduction?
This particular call is primarily for advanced systems or advanced reactor concepts, not necessarily studies for their economic feasibility.
Does ART also include integrated systems you mentioned for HTRs?
Integrated systems, we have a high focus on that in both fast reactors, and it can be explored in the high temperature reactor realm as well. So system integration will be an important part for all advanced reactor concepts.
Are new material systems appropriate to propose to this area?
New materials, if referring to enhancements upon current systems or components, new materials, then that could possibly fall into this purview, but we're looking more at systems and components, not necessarily materials. I believe there are other scopes focused on that particular aspect.
What are the research issues for graphite?
Research issues for graphite, that is not necessarily my area of expertise, so I would have to follow up with the technical lead on our graphite program for that.
Are new fuels being considered for the MSRC1 area?
With this, innovative fuel cycles have been explored in the past and are still underneath this scope, so that's correct for advanced reactor regime.
Would any concept relevant to LWRs be considered, or just high temperature reactors?
We are primarily focusing on generation 4 reactors. High temperature reactors are a subset of those. We are not necessarily looking at innovative non-light water reactors at this time.
How do the NUP advanced reactor concept scopes relate to the recently announced DOE advanced reactor industry-led R&D?
These particular scopes for the NEAP program, we are looking for either enhancements upon the R&D related research, or we're looking for further systems that are more advanced and maybe more far in the future than the near-term scopes that have been developed in this recently generated funding opportunity. So this is more of an innovative, outside-the-box type call. So,
are pebble bed reactors still considered, even though the U.S. isn't necessarily pursuing them?
Pebble bed reactors can be considered in this category. That's correct.
What amount of RD, D&D are you interested in for these new systems? Are industrial collaborations encouraged?
Industrial collaborations, they could be utilized in this particular venue as well. Right, so RD&D and utilizing industrial collaborations, is that what I understand? Right. Yes, in the past people have proposed working with certain aspects of industry for experimental work or items like that.
Are new graphite concepts considered?
If it's within the Gen 4 scope, then yes, that also can be considered in this.
Is there interest in analyses of breed burn systems or approaches to lower DPA and high burn-up SFRs?
Looking at high burn-up SFRs, yes, we're looking more for burner type designs for our particular scope. We generally try to avoid breeding type reactors.
How many awards are expected in this area?
And that I'm not able to ascertain at this time. It will develop on our future budgets. So.